This is a key to topic 19, worksheet extra 5A, and you are asked to simplify each of the following and make sure you show the work for each of those as well. So let's go to number one. So number one, we have negative 12, negative square root of 12pq squared. Now, what you may want to do is to rewrite this using the product rule for radicals. Now, in these problems, for the most part, you're dealing with square roots and there is a cube root and a fourth root. But the property for radicals says that if you have in this case, a square root of a product, then you can rewrite this as the product of each individual square root. And so I can rewrite this as the square root of 12 times the square root of p times the square root of q squared. Okay, now you need to simplify each of those individual square roots if you can, if it's possible to do that. So for the square root of 12, it is possible to simplify the square root of 12. So the square root of 12, to simplify that, remember you're looking for the largest perfect square, since it's a square root, you're looking for the largest perfect square that goes into 12, and that is 4. So I can rewrite square root of 12 as the square root of 4 times the square root of 2. I'm sorry, times the square root of 3. And so I can simplify the square root of 4 even further. That's just 2, so I get 2 square root of 3. So that is this. So that becomes negative. And then remember the square root of 12 is simplified to 2 square root of 3. Now I cannot, let's talk about the square root of p for right now. So remember that if the exponent of the variable here is less than the index, this cannot be simplified any further. So p to the first, since the exponent's 1, 1's less than the index, and the index here is 2, then you cannot simplify this. So we can't simplify further, okay? And so therefore, I'm just going to rewrite this over. So square root of p will stay square root of p. Now for the square root of q squared, let's talk about that, square root of q squared. So remember, you need to ask yourself what times itself is q squared. So that's what the square root of q squared means. So this right here is what times itself twice is q squared. Well, that's easy. That's just q times q. Q times q is q squared. So the square root of q squared is q. Now again, we're going to assume that all these variables represent positive numbers. So we don't have to worry about absolute value anywhere in our answers. Okay, also remember there was a property in that you learned that a quick way of simplifying this is to look at the exponent divided by the index. 2 divided by 2 is 1, so notice you get q to the first. Okay, so this simplifies to just q. Now, you don't want to leave your answer like this because you remember, you know that when multiplying radicals, if the indices are the same, square root, the indices are both 2's, then you can rewrite this as 1 square root. Then we're going to put this on the back end. So I get negative 2q times the square root of 3p. And that's the answer for that one. Okay? So there's a lot of discussion here, a lot of things you had to think about as you went through this process of simplifying this radical. All right, number 2, we have the square root of 75, a to the 7th, b to the 4th. All right, and again, just like we did here, I'm going to rewrite this as the square root of 75 times the square root of a to the 7th times the square root of b to the 4th. All right, so I'm using the property, the product property for square roots. Now let's talk about the square root of 75. So let's go off to the side. Let's go off to the side and talk about the square root of 75. So is there a perfect square other than 1 that goes into 75? And always use the largest. Makes things a lot easier for yourself. And the answer is yes. 25 is the largest perfect square that goes in 75. So I can write this as the square root of 25 times the square root of 3. And the square root of 25 is 5. So I get 5 square root of 3. So this right here becomes 5 square root of 3. Okay? Now let's talk about the square root of a to the 7th. So let's talk about that. Okay, so so I can simplify this because the exponent is greater than or equal to the index. But this is not that easy because 7 is not divisible by 2. So remember how we're going to do this. You want to think about, well, what is the largest whole number less than 7 that's divisible by 2? And the answer is 6. So that means you can rewrite the square root of a to the 7th as the square root of a to the 6th times the square root of a, right? Because a to the 6th times a to the 1st is a to the 7th. And now you know you can simplify this. 6 divided by 2 is 3. So what times itself 2 times is a to the 6th? Well, a to the 3rd. And I cannot simplify the square root of a because the exponent of 1 is less than the index. So the square root of a to the 7th is a to the 3rd power times the square root of a. So that goes here. So times a to the 3rd square root of a. All right. Then we do the same thing with the square root of b to the 4th. I can simplify this because 4 is greater than or equal to 2. This is easy though. 4 is divisible by 2. So if you think about that, what times itself twice? The index is 2. So what times itself twice is the Bradicand b to the 4th? Well, it's b squared, right? And we knew that this had to be b squared because 4 divided by 2 is 2. All right, so that becomes b squared. Okay, so just like we talked about here, you would need to rewrite these radicals, this product here, as one radical. So let's put that on the end, though, of our answer. So I'm going to get 5a cubed b squared. So 5a cubed b squared times the square root of 3a. All right, so that's number 2. Okay, let's talk about number 3. So in number 3, we have 4 times the square root of 6 x to the 4th y to the 7th. All right, and so I'm going to rewrite this as 4 times the square root of 6 times the square root of x to the 4th times the square root of y to the 7th. All right, and I cannot simplify the square root of 6. The only perfect square that goes into 6 is 1. Now I know I can simplify the square root of x to the 4th, right? It's kind of like this one right here, like the square root of b to the 4th. So the square root of x to the 4th, what times itself twice is x to the 4th? Well, that's going to be x squared. And we knew that this had to be x squared because 4 divided by 2 is 2. So this becomes 4, square root of 6, and this is just x squared. Now let's go back the square root of y to the 7th. All right, square root of y to the 7th. So I can simplify this because 7, the exponent 7, is greater than or equal to 2. But 7 is not divisible by 2, so I got to rethink this. How can I rewrite this? Well, I can rewrite this. So remember, you want to rewrite this in such a way that whatever exponent you use is divisible by 2. So what's the largest whole number less than 7 that's divisible by 2? And always use the largest. It makes things easier on yourself. And so that's 6. So this becomes y to the 6th times the square root of y. When you multiply like bases, you add exponents. 6 plus 1 is 7. And the square root of y to the 6th, 6 divided by 2 is 3, so that's just y cubed square root of y. So that goes here. Y cubed square root of y. And then your final answer, you want to rewrite these two square roots as one square root. So your answer is going to be 4 x squared y cubed times the square root of 6y. All right, so that's the way you need to write it. Okay, number 4. So let's do number 4. So number 4, we have 6 times the square root of 25, a to the 6th, b to the 5th. All right, and so I'm going to rewrite this using the product rule. So this will be the 6 square root of 25 times the square root of a to the 6th times the square root of b to the 5th. And then the square root of 25 is 5. That's an easy one. So this becomes 6 times 5. This one's easy too. I can simplify this because the exponent 6 is greater than or equal to 2, which is the index. And it's also easy in the sense that 6 is divisible by 2. So when you think about this, when you think about what this equals, you're asking yourself what times itself twice is a to the 6, and that's a to the third power. 6 divided by 2 is 3. So this is a to the third. Okay? Times. Now, I can simplify this because 5 is greater than or equal to 2, but it's not divisible by 2. So let's think about how to simplify this further. So the square root of that's b to the 5th. So what whole number less than 5 is divisible by 2? And so that's 4. So I can rewrite this as b to the 4th, square root of b to the 4th, times the square root of b. 4 plus 1 is 5. And square root of b to the 4th is just b squared. I cannot simplify the square root of b. And so this right here, I'm going to rewrite as what I just wrote there, b squared, square root of b. And the next thing you want to do is to rewrite this in a better way. 6 times 5 is 30. And always, now there's only one square root here, so put that on the end. And we get 30, a cubed, b squared, square root of b. All right, number 5. And number 5, we have the cube root of 16, x to the 8th, y to the 13th, z to the 17th. All right. And so again, now remember this time it's cube root. So we have the cube root of 16, so rewriting it as a product, times the cube root of x to the 8th, times the cube root of y to the 13th, times the cube root of z to the 17th. Okay? All right, so let's ask ourselves, can I simplify the cube root of 16? So is there a perfect cube that goes into 16? All right, so this time you're dealing with perfect cubes. And the answer is yes, 8. So I can rewrite this as a cube root of 8 times the cube root of 2. And the cube root of 8, what times itself 3 times is 8? And the answer is 2. So this is 2 times the cube root of 2. So that's going to go here. So this is 2 times the cube root of 2. All right, so let's go back. Let's simplify the cube root of 8, x to the 8th. Okay, so I can simplify this because 8 is greater than or equal to the index 3, but 8 is not divisible by 3. So think of what is the largest whole number less than 8 that's divisible by 3. It is not 7, but it is 6. So I can rewrite this as a cube root of x to the 6th times the cube root of x squared. 6 plus 2 is 8. All right. And then the cube root of x to the 6th, 6 divided by 3 is 2, so that's x squared. Kind of makes sense, right? Because look, so if you think about the cube root of x to the 6th, when you think about what that equals, so you're asking yourself, what times itself 3 times is x to the 6th? And that's just x squared. When you multiply like bases, you add exponents. 2 plus 2 plus 2 is 6. So that's just x squared here. All right, so this becomes x squared times the cube root of x squared. Okay, so that goes here though. So this is times x squared cube root of x squared. Okay, now let's simplify the cube root of y to the 13th. So let me go ahead and kind of talk about that here. So the cube root of y to the 13th. So I can simplify this because 13 is greater than or equal to 3. But it's not as simple. 13 is not divisible by 3. So think about what's the largest whole number, less than 13, that's divisible by 3. And it is 12. 12 is divisible by 3. So I can write this as the cube root of y to the 12th times the cube root of y, because 12 plus 1 is 13. And then the cube root of y to the 12th, 12 divided by 3 is 4, so it becomes y to the 4th, cube root of y. So that goes here now. So times y to the fourth cube root of y. Now let's talk about the cube root of z to the 17th. Let's simplify that. So the cube root of z to the 17th. I can simplify this because 17 is greater than or equal to 3, but 17 is not divisible by 3, so we got to delve into it a little bit more. So what's the largest whole number less than 17 that's divisible by 3? It's not 16, but it is 15. So the cube root of z to the 15th times the cube root of z squared, because 15 plus 2 is 17. And then the cube root of z to the 15th, I can rewrite in a better way. 15 divided by 3 is 5. So that's z to the 5th times the cube root of z squared. So that goes here. So times z to the 5th cube root of z squared. Okay, now remember you need to rewrite this. So see all these cube roots? Cube root of 2, cube root of x squared, cube root of y, cube root of z squared. You're going to write as one cube root. All right, because remember there's a property that says when you're multiplying radicals and the indices are the same, all these indexes are the same, you can write it as one radical. But we're going to put that in the end. So I'm going to put the 2 first, then the x squared, then the y to the 4th, then the z to the 5th, and then I'm going to write the radical. The cube root of 2 x squared y z squared. And there's your answer. All right, so that's the answer to number 5. And then finally, number 6. So let's do number 6. In number 6, you have 3 times the 4th root of 16, x to the 8th, y to the 3rd, z to the 10th. All right, so rewriting this, I can write it as 3 times the 4th root of 16 times the 4th root of x to the 8th times the 4th root of y to the 3rd times the 4th root of z to the 10th. Okay? So using the product property for radicals. Now let's go ahead and simplify each of these if we can. So I get 3. Now the 4th root of 16 is 2. Okay, because think about it. The 4th root of 16 is 2. 2 times itself 4 times is 16. Okay, so the 4th root of 16 is 2. So that's 3, and this is just 2 times. The 4th root of 8 I can simplify because 8 is greater than or equal to 4. It's easy though because 8 is divisible by 4. So the 4th root of x to the 8th is x squared. So x squared times itself 4 times is x to the 8th. I cannot simplify the next one because 3, the exponent 3 is less than the index. So I cannot do anything else to this. I'm just going to rewrite it. 4th root of y to the 3rd. And then I can simplify this one because 10 is greater than or equal to 4. But 10 is not divisible by 4, so I got to think about this. So let's talk about how to simplify the 4th root of z to the 10th. So I got to think about, well, what's the largest whole number less than 10 that's divisible by 4? It's not 9, because 9 is not divisible by 4, but 8 is. So I can write this as the 4th root of z to the 8th times the 4th root of z squared, because 8 plus 2 is 10. And then I can simplify the 4th root of x to the 8th, because 8 divided by 4 is 2. So that's z squared times the 4th root of z squared. So that goes here. So times z squared, 4th root of z squared. And now what you want to do is, again, don't leave the answer like this. For one thing, you know 3 times 2 is 6. Another thing you know is that these two radicals I can write as 1 because they both have the same index. So this becomes 6 x squared z squared times the 4th root of y cubed z squared. All right, and that's the answer. So that is the key to the worksheet on topic 19, extra 5A.